Right. So I'm not too sure whether all of you have worked with big data or data engineering related projects, specifically with Spark clusters. Okay. I've been working with many different type of projects. Not directly with Spark clusters, but we have various type of Spark-based implementations like DataFrame, Synapse. Okay, and even before that, we were working with HD Insight. And if you really think about on-prem environment, we had Hadoop, right? So we were working with various platforms, and we noticed that we just can't stick into traditional data warehouses, which are structured data warehouse where you see facts and dimension. So we had to move into a sort of distributed environment for handling complex data, semi-structured data, unstructured data. That's how we started working with Spark. Before Spark, what we had was Hadoop, which was fully optimized for batch processing. We had some difficulties in terms of when we see velocity with data, but then Spark came to the world, and everyone started working with Spark. And most of new modern database platforms, database engines have been designed based on Spark. Okay. Before we talk about Hyperspace or adding indexes on data lake files, okay, it should be Azure Data Lake files. Okay, so I have made a mistake with that. So before we talk about it, let's try to understand how we have been working with Spark and why we didn't see this type of things initially with Spark and why we need it now. All right. So this is what we have seen. We were working with traditional data warehouses with facts and dimension tables, and then we started taking semi-structured, unstructured data into our analytical work, right? So that's why we started seeing distributed processing environment, distributed storages, so HDFS, data lake, things like that. Okay, but when it's come to engine like Spark, we always work with the data that have been stored somewhere else. Okay, now for example, when you work with Spark, you'll be using the data storage as blob storage, HDFS, or data lake. That's how it works. So we never consider to have a sort of a permanent database with Spark. Now you might say that okay, we can create databases with Spark. Yes, we can create Spark tables, Spark databases, Hive tables, Hive data warehouses, Hive databases. Yes, it is possible, but we never consider these databases as the standard databases we have seen. So because of that, the key things what we have seen with databases were not there. Now, for example, that ACID properties, okay, the proper transaction properties. That is something we always see with standard database management system like Microsoft SQL Server, Oracle, MySQL. That is for mainly maintaining the consistency of the database and handling transaction, handling failures and all. But we didn't see anything like that with Hadoop and Spark. There were certain mechanisms, certain sub-projects to handle these things up to some extent, but we didn't see with the core part. Okay. Actually, we didn't want it because we were focusing on set of data that have been stored, or we were accessing data coming from something like IoT devices, let's say streaming channels, and then we process them then and there and produce results. That's what we have been doing. But nowadays, you might have seen this, you might have noticed this. When we design data warehouses, when we design analytical store, it is not always like extract yesterday data and then place or fill the analytical store and then continue with analytics. That's not what we see with modern world. Earlier, that's what we have been doing. But now we need to get all of these things immediately. Okay, it could be something like streaming sources, but forget about streaming sources. You might have a very high transactional database. So you might be extracting data every 5 minutes, okay, and place them into something like data lake. And then you need to get that data and process and push it to your analytical stores, right? So when you have requirements like that, one of the challenges we had was, handling changes or finding some, high select or executing high selectivity type queries. Now, I'm not going to talk about how to handle changes and how ACID support we see with Spark. We'll try to have another session on that. I'm sure that you have heard about something called Delta Lake. So Delta Lake is the one we have for ACID type of things, right? But we wanted to have something like that with our Spark engines because we saw the requirement, right? In addition to that, we noticed that rather than creating these standard tables like facts dimension tables in the data warehouse or databases, we try to create logical data warehouses, external tables with the files in places like data lake. I don't know whether you have already started implementing things like, am I getting a message? Give me a second. Yes. Okay, Pradeep, I don't have slides. I have only this and the blank slide. Okay. So don't think that I'm not, something has gone wrong with my machine and you don't see the slides. I don't have slides. I have a blank slide just for have the, what do you call it? Whiteboard discussion. Okay, right. So I was explaining this. So we noticed that rather than creating data warehouses or fixed table, permanent table, people try to move data to places like data lake or the blob storage, and then try to build tables on top of that, okay, without performing much ETLs, without allocating space for data warehouse or the permanent databases. I'm talking about something like this. Okay, so let's say this is your environment, this is your analytical environment. Okay, and you have various type of data sources. It could be databases, IoT devices, social network. Okay, so many things. So you get data, and generally what we have is a storage like data lake. All right. Okay. So this is what we see with modern implementation. We get the data into this. So if you think about standard implementations, what we have is like, raw layer, curated layer, then, one layer, one zone for, let's say, MIS department, another zones for finance, something like that. So you place all your, files into this. Of course, you need to organize it well, and you might, process them and put it this curated layer. This is what we do now. If you really design a big data solution or analytical solution, this is what we do. All right. And in addition to that, you create your data warehouse, then extract data from this to this. If you think about real enterprise type of big data warehouse implementation, this is what we do. But there is a new trend. I don't know whether you agree with me or not. I'm trying this with my current project. So let's see whether it will work or not. But I have seen that people try this. Rather than creating this, okay, you open these files or data files. You will be having millions of files, organized with multiple folders, and you try to create a logical structure. Okay, logical structure, and open this as a database for all other users and applications. So this is not a physical database. In a way, this will be the best way of opening data, because when you try to maintain a data warehouse, permanent data warehouse, okay, it's very difficult to maintain with changes. Okay, but if you maintain a logical data warehouse, okay, then it could be one of it will be really easy to maintain. It you will be able to easily address changes, new requirements. So we try to have something like this with modern implementation. So it's all about showing tables, okay, for external parties, users, but the reality is data is in the data lake. Okay, so when you open something like this, now you get some issues. If it is something like let's say collection of or aggregation, grouping, then it might work well. But when you try to get small set of records, when you try to filter, you might have to go through large number of records to find small set. Why? Even though this is it will take long time. Why? Because even though this looks like a database. This is not a real database. So we don't have anything like indexes. Okay, we don't have indexes with this because this is not a database. So this requirement was there for a long time, and we had no way of addressing it. But luckily, Microsoft has worked on it. Anyway, it's open source. Okay, now we have a new subsystem, okay, called Hyperspace, which can be used for adding indexes on files in your data lake. Okay, so we can simply add indexes to the files. It doesn't mean that you have to have indexes on all the items you have. Just make sure you understand users' request, and based on that, you can create indexes. That will really help for queries like, high selectivity type of queries with where clauses. So what I want to highlight with this session is that part. What is Hyperspace and how we configure, how we can work with it. Still, even though it can be used, as per articles I have read, it is not fully implemented yet. Okay, so because of that, there can be future changes. There can be new ways of implementing it. But let's try to understand how it works. So what I'm going to do is I have already loaded set of files to my data lake, because in order to see the different, still we cannot see the different. I have loaded somewhere around 200 million records from one of the sample text files in Synapse. I'm going to use Synapse environment. Okay. But still, I don't see much differences. But only thing is we can go through the plan and see how indexes are being used when we query. So I don't have a data warehouse, logical data warehouse built because it's too early to see all these things. But it's better to understand what sort of things we are going to see as a part of Hyperspace and get ourselves ready. If you might be planning for a data warehouse solution, you might be planning for big data solutions, you might be thinking an implementation like this. So in that case, it is better to get yourself prepared. So that's what I'm trying to do. I'm trying to help you. I'm also still learning on this Hyperspace part. Okay, but let's see how it works. All right. So let's go into Synapse, and let me open one of the code I have already written. I think the right one is shared. Let's see.
Yes, we can see that. Azure. Yeah.
All right. OK, Synapse environment. I'll explain this. I just execute one of the codes just to make sure my cluster is getting started. Started. I should see an error with this. That's fine. Just want to make sure that cluster is getting started, because so I'm not going to explain what is Synapse and all, but let it run. Let me explain how I have configured this. Okay, right. This is what I have done. So I have created my Synapse environment, right, and it has a cluster, and this is my Python notebook, right. What I have done is, anyway, this similar code can be, I have made some changes, but similar code can be seen with Microsoft Docs. So what I have done is I have imported this taxi data, right, from Azure ML Open Dataset, right, and I have imported from 2017 January to 2018 December, right. So I have loaded into a data frame, and this is a sample dataset. So you can see this has vendor ID, trip, start time, end time, distance, and the number of passengers. And then we have multiple values like payment type, fare amount, tip given, total amount, year, month, and things like that. OK, so what I have done is I have loaded this into a data frame. OK, I hope everyone can understand this. It's a very simple code, right? And then I have just created a view. OK, I have just created a view to make sure I get the count. Since I execute this one, now I'm not going to see it. I have somewhere around 200 million records. OK, I'll show the how it has been stored. So what I did was I store these 200 million records in 2 different folders. I named one of the folders as Hyperspace and another folder as Hyperspace Index. OK, I executed all of these things because it takes somewhere around 10-15 minutes for completing the whole thing. Right. So I'm going to start from this point onward. So let me quickly show you the data I have. if I go to my the one in my Synapse link data sources, and this is my primary container. Inside that I can see Hyperspace. Let me refresh this. Right. So since I executed, since I executed this code, all right, so it creates temp folder, TMP folder, and it creates Hyperspace and plays Parquet files. I'm placing all these files as or data as Parquet files. So if I go into this, I can see a temp folder. If I go into temp folder, I can see two folders. If I go into Hyperspace, so all these are Parquet files. Okay, there are 56 Parquet files. So altogether, these 56 files, you can see average size is like 80 MB, 90 MB. So we have somewhere around 200 million records. And I have the other folder as well, which is the index. Folder has been named as index. So I'll be using this folder for applying indexes. OK, I can actually go to the other tab and see this. So in the main. So this is my storage, like directly connecting with the storage. So we have temp and Hyperspace and Hyperspace index. OK, but let me go into a different folder in this. If you go to Synapse, the main system folder, we have workspaces. Inside that, we have a different folder that is for something else, right? But other than that, we don't have anything in the Synapse workspace. All right. Now, what I'm going to do is I'm going to write some codes to just to get the data loaded again to the data frame, and then let's write a simple query and see. OK, so let me write a code. I hope it is visible. Let me see whether I can increase the font size. All right. So I'm going to get data. So let's say I want to define a variable called data frame loaded, and I'm going to say spark dot read dot I should say load, and then I have to say slash temp. Let's say Hyperspace. I'm going to load all the files from this. OK, and then I have to say format is Parquet. OK, and let me say in first schema is true. All right, I just want to see whether I can load this. Let me execute and see. So I'm trying to load data from one of my folders. I'm sure that I have made a mistake somewhere here. Path does not exist. Sorry, no, it's not temp, it's TNP. All right, so it looks like it is OK. Let me write the second code. So once this is loaded, we can actually easiest way is like, and I always prefer to work with Spark SQL, because rather than writing Python and Scala code, I can simply write SQL code. So what I'm going to do is I'm going to get this. That is my IntelliSense. Why I'm not getting it? Oops, sorry. So, okay, here I got load. So there's a method called create. That's really bad. IntelliSense is not coming. So I'll type it create okay, here it came, create or replace view, and I'm going to create a view to access this data frame through SQL. Let me execute this. View is created, and then I should be able to access through SQL. So I prefer to write SQL statement. OK, that's why. So let me have the magic command, which is SQL. Now I can write select statement inside my Python notebook, right? I can say where, let's have a look and see 100. Let's see whether it works. So we are going through 200 million records. Let's have a look on the count as well. Okay, I can see records. Okay, these are the records. Let me just hide the output. Right, let's get the count as well. Let me say SQL select all from. Sorry, not all. Let's say count. Okay. Right. See, we have 216,090,511. Right. So that's the number of records we work with. Now I'm going to write a different type of SQL statement and see whether it works well. Okay. So let me take a new code. SQL select. I'll write something on this from this table, right? From this view. I'm going to say where we have year and month column, so which is PU year. Let's say 2018 and PU month equal to then let me have PU year, PU month, and I'll have two aggregations from tip amount. We have the column name as tip amount, and then another aggregation total amount. I can remember these columns because I have tested this multiple times. And we need to have grouping. So let me copy this. Group by. Okay. Right. So I'm going to execute this. Let's see how long it takes. So I'm going to just see the original time because I don't want to execute again and again because it is getting cached. All right, so we have the result. I can actually go through Open Spark UI and see the graphical tree as well. But if I just expand jobs, I can see 5 seconds, 1 second, 1 second. If I execute this again, this will be treated through the cache. Okay. So because of that, I'm not going to execute it again. What I'm going to do is I'm going to make some changes to my other one, which is Hyperspace index. Let's see how we can add an index. Okay. And then, execute the same type of query against that. Right. Just remember, the total time is somewhere around 5 seconds or 6 seconds. Okay. Right. Let me add a new code. I can actually copy from the top. So I'm going to save this code. These things, so it's easy to copy and paste, right? Rather than typing. Get this as well. I'm going to name this as index, even though we don't have indexes yet. Okay, I'm just naming this as index. And we have to refer index table. So once it is loaded, I can have a look on that display. This limit with this, right? Limit. I'm not too sure about this command. Anyway, let me run the first one and then. So I'm loading it to a new data frame that is from the other folder. OK, so I'm now working with where is it? I'm working with this folder now. All right. Both have same number of records. I execute this. Executing. Hyperspace text. All right, done. And let me see whether I can actually see the records of this. So it's very difficult to remember all these codes because we use SQL, Python, Scala. So the syntax are a bit different, right? So it's very difficult to remember the patterns of all the codes. All right, so it works. So we have loaded data into this data frame. Now what I'm going to do is I'm going to add an index on this data frame. Now you might ask why I add indexes to this data frame. Currently, we have no way of just going to the disk. OK, going to the disk, I mean, to this folder and add indexes. So what we have to do is we need to load all the data we have in this folder to a data frame and then add indexes. OK, right? So that's what I'm going to do. Let me write a new code for this. I need to import some libraries. Hyperspace. I can say import all, right? Then from there are few Microsoft Hyperspace, and certain things I'm also not too sure whether we really need it. OK, because we don't, it's very difficult to find complete information on this. But I'm loading this hyperspace dot index import. So I'm instantiating it. I'm going to hold everything in a variable called HS. We'll be getting a method called hyperspace. I think it is case sensitive. OK, right. Let me execute and see whether any problem with this. No, right? Right. So we have loaded required libraries. Now, how do I add indexes? Now, if I check this query, OK, this is what I want to execute. If I check this query, we know that it is better to add an index on these two columns. Now, if you remember standard indexing, what we have discussed with SQL Server, right? If you have filters like this, it's always better to add an index or make the index as a composite index. So I can add these two columns to my index. In addition to that, I can actually use other columns. Now, this is year and month, but we are aggregating amount and tip amount and total amounts. So in that case, it is better to aggregate. It is better to have these two columns with the index. So do you remember included column concept with SQL Server? So we can have the same. OK, so how do I add this? Let me show you. I'm going to say that I have to give a name for sort of index. So I'm going to say, let me take this index. Can't use the same name, right? Oh, sorry, this is my data set. So I have already loaded data set, if I'm not mistaken. Yes, so we have this data set, right? So what we have to do is I'm going to say I had to import another one, which is Hyperspace. I need to import something called index. Listen, all of a sudden it is not working. So I believe that this is correct in config. OK, so I'm going to import this and then I'm going to use HS, which is the one I created with my previous cell. All right. And then I should have create index, not getting. OK, so now I have to type it, create index. All right. On what? This loaded data frame. OK, so this is how you really create the index on that folder. You cannot straight away access the folder and create index. You have to get the data loaded into the folder. All right. And then I can say index config. If you want, you can actually define index config separately and add it. But let me have it with this. So index config accept three things. First thing, name. So let me just say index 01. That's a name. Second one, your index column, one or more columns, right? So it should be a collection. And I'm going to say PU year is one column and PU month is another column, right? And third parameter is included columns. So we have tip amount, okay, and total amount. All right, so I have defined my index. This should create an index. Let's execute and see. Okay, it is getting executed. So what happened is actually it creates additional files. It creates metadata and it creates additional file for this. Now, if you remember the non-clustered index concept, it is same. It creates a copy of, year, month, tip amount, total amount, and place it somewhere else. That's what's happening here. So it creates an additional folder in your data lake. So indexing, just like normal databases, it increases the size of your data lake. Okay, so that's something you have to remember. It's still running, and I can actually go to my, while it is running, I can go here and refresh this and see whether it shows anything additional. Going to workspace, do you see anything additional? No. Okay, if I go into warehouse, see, I can see indexes folder has been created. An index 01 folder has been created. If I go into it, I can see if I go to this folder, I can see the same set of complex Spark files. So this is your non-clustered index data. So now you have two sets, your original data set, which is in TMP, this folder. In addition to that, you have data in the system folders as well. Okay, right. So the index has been created. Now I can actually check and see whether this index really helps. But I'm going to write another code to clearly see whether index is being used or not. But let's take that SQL code and see whether we have some sort of improvements. And I need to use this. Right. So now let's execute and see whether it gives data quicker than the previous one. Okay, so I can see 2 seconds. Earlier it was somewhere around 5 seconds. So we see some slight improvement. Of course, in order to see a bigger improvement, you need to work with billions of records, billions of files. This is a very simple in that case, right? So this is one way of checking it. Let me show you another way to see all of these things. Before that, how do I know how many indexes are there? One way is I can go to my storage and go through the system folder, like Synapse, workspace, warehouse. Then if I go to indexes, I can see one folder here. So then I know there's an index called 01, but I can simply use my HS, the instance I have created, indexes, indexes.show, I guess. Let me execute. Indexes, that's correct, right? Oh, sorry. See, it shows there's an index called index 01, and these two are the index columns, and these are the included columns and the structure. If you really want to expand these and see, rather than typing like this, you can can use the display method. Okay, this is the beauty of Spark. There are many methods to do the same thing, and the output will be different. No, not sure. Sorry for that. Work. Yeah, so now you can see a table properly, and if you expand it, you can see the columns, right? I mean, everything can be seen properly. Right, let's do another test, a quick one, all right? What I'm going to do is I'm going to, this time let me work with DataFrame rather than using SQL, because I want to use DataFrame commands for doing, few things. Right, what I'm going to do is I'm going to load the data again to another data frame. Let me copy the code again. Where is it? There are multiple ways of loading, right? This is one technique. Okay, I can say index, let me say 02. Okay, this is one way. Or else I can simply say spark.read. Parquet, for example. See, I can say Parquet and then the file. Let's use this. Okay, this is another way of loading it. Let me execute. Right, done. So data frame is loaded. You know how Spark works, right? Even though this is executed, data has not been loaded yet. That's how we see it. Right. Okay. I'm going to execute a different query now. Okay. I'm going to have a different data frame, df1, and I'll be taking that data frame. Okay. Let me say I'm going to filter. Okay, filter. So you need to have when you have the filter, you need to have double quotes. I want to filter it by tip amount. Okay. Greater than 2. So I want to find out all the records that have, tip amount greater than 2. Okay. And then not all the columns. Let me say select. Let's say vendor ID. There's something called vendor ID. And, let's take passenger count. And the last column is trip distance. Okay, so this is the filter I want to make it to have like this. Okay, and let me say df1 dot show and df1 dot explain true. Execute and see. So I'm getting records based on this condition. All right. And if I scroll down, I can see the explanation. I'm going for the physical plan. And you can see when it's come to physical plan, the data is being read. You can see in memory file index, but that's not what we are focused. See the path. It is getting data from what? My normal folder, TMP hyperspace index folder. Why we don't have an index satisfying this type of filter? So let's add an index and see whether plan is getting changed. So I can add an index. Let's say define index config separately. Config, let's say tip amount or the tip, right? So index config. First thing is name. So let me say it is index 02. Then my index column in this time. What I'm saying is tip amount only. So I'm going to create an index on tip amount. And included columns, I have two. I have actually three. Vendor ID, passenger count, and the last column, trip distance. Okay, right. I have created the config, and then let me say HS create index. Create index. We can say this is the data frame. Okay, and this is the config file, index config tip. Let's execute. In the meantime, let me copy this code and come back, which can be used for seeing indexes. Right. So once this is executed, I can check and see whether new index has been created or not. After that, I can execute this code again and see. Let me copy this. While this has been running, I can do this. This time I'm going to say it is F2, right? So once is it done? It's still running. Okay, so this creates another index, which means it creates another folder in my data lake. So once it is done, I can test this one. Let me add another code. That's going to be my last code part. I'm going to have another copy of this because this allows me to actually compare and see. So I'm going to say this is 3. Okay, same thing, 3. And rather than saying show, let me say spark dot. We are going to make a small change to the context. So that's spark dot hyperspace dot explain. That's an API. Display mode. We say nil. Okay, and then I can say h dot explain ef3 true and display HTML. Okay, so let's see. Right, this is done. So if I go into this, if I refresh this, I should see another folder. See, I can see another folder. That's my non-clustered index folder. Right, now I'm going to let's execute this as well. Let's see whether we see both 2 indexes. I can see 2 indexes now. All right, and let's load data into DataFrame 2 and see. Same thing. Right, we got the data. If you really compare the speed, you can see. It's also 1 second anyway. Right, but if I scroll down, if I go to file scan, oh, it has not used my index. It's still reading the same file path. Why is that? It still uses my original file path. I should see the new index file path. So vendor ID, passenger count, and trip distance. Vendor ID, passenger count, trip distance. That's correct. Strange. I can actually force this and see whether it really works. Hyperspace enable Spark. Execute and see. Sorry, it should be capital H. See. Yeah. So I have to pause. Now, can you see the path? Now it takes from index folder, not from the original folder. So this is how it really uses index folders. Okay, we can actually using this explain API, we can see it. If I execute this code, it highlights saying the file scan originally it takes from this. Okay, but if you use if the index is being used, it will take data from this. Okay, this is just a I believe that this is a start of everything. Start of indexing. We'll be seeing various type of indexing later for sure. All right, but it is better to plan it out and then see whether you can really use when you plan for your big data and data warehousing part. All right, that's all I have from my end.